Okay, we will look into linked lists, single linked list, double linked list, and eventually we will also look into queues. Um, so the entire linked list structure relies on nodes. Nodes is a type of object we depend on and which we create initially. That node is just like one, like I guess I would say like an item in a list, right? And that item would inherently have two distinct values. One would have uh, its own value or the data it is stored inside it, and a reference or like a pointer or like an address to the next list or next element it is pointing to. So a node essentially would have like two details in it. As I mentioned, a value of its own and what it is pointing to next, right? So in single linked list, what we essentially do is when we initiate a linked list, we start with by creating a node with initial value of -1 and pointing in both head and tail to it. Now, when we add element, get element, and delete things on it, we we rely on that dummy node. This here's the thing. This node with value -1 is just a dummy node where our head is pointing when we start and also tail is pointing, but it is just something we created to make to make things a lot more easier in the other function. I have tried writing this code without a dummy node, and it is in fact possible, I believe, but it gets much more challenging to understand. But when we create like just a dummy node or a fake node, um, to keep track of things where the list starts and where it, you know, so it's very crucial for single linked list. We create just one node. As we yeah, let's just remember that for now. Now we are writing a get function first. What the get function does is we are giving it an index and it returns in the value of that index. Okay, so we would put like an integer. We will start like loop kind of thing over the list. We would start with I as in 0. We will start with 0, and we would put like one cursor or like current variable or like current pointer. We would start it actually with self.head.next. So we want to start with head. We want because the head is the dummy node. Now, here's something that you need to think of. In get method, we are trying to retrieve value from that index. So we don't need to shift anything or anything like that. Like we can just directly go to that specific index. We don't need to stop before that. So that's why we start with head.next, which means the original value. Like if we had put in like value of 19 as our first element, we would start with 19, not -1, because self.head is pointing to -1. Okay. Now, as long as the current uh, pointer exists, we would keep looping. If the index is I, we will return the value. Oh, this is the current value. If not, we will keep incrementing and with the I and current as well. And at the end, we will return -1 if we don't find anything. Okay, now the other method is insert at head. And we don't return anything. Okay, so insert at head, we create a new node and we assign it new node, right? There is a value to it, right? Now, what would be the new nodes next? That would be the self.head.next, like whatever the first element it was originally when we say like, oh, let's say 19 was the first element. So our new node should be pointing to 19. So new node next is 19. Now our head So next, -1, so next should be pointing to new node, right? Right. Now, here's the condition. If it is the first node, if it's like an empty, if it was like an empty list, about our tail was also pointing to -1. So we also need to change that and make that tail point to our new node as well. Another function is insert at tail, which insert that tail. We created a new node. Self.tail points to the last element. We are pointing that last element's next to our new node, right? And we are taking our tail to the new node, right? Now, the remove function gets a bit tricky because what we are essentially doing is that we are stopping a point or like an index before, like one index before the index we want to remove. So what we would do is we would step a step before that, and we would do like node dot next dot, yeah, we would do node dot next equals to node dot next dot next, so that way the middle element is out of the loop, even though it might be pointing to the its original next. But what we are doing is we are just skipping one loop. Okay, so that's what we do. We are actually in here starting with the -1 node and with 0 because we are stopping at that index, right? Okay. While index is less than, I is less than index, and current element is valid, we keep going. Now, uh, this will, I is less than index. So it starts from head as 0. So the one which is not supposed to be 0 becomes. So it increments to 1, which becomes index, which is stopping at index. But since we are starting a step further from self.head, it would stop actually a step before head, right? Uh, I would say like make like a list of your own, like on your notebook and paper. No, notebook and paper, and like try to visualize how things work, and it will it would make a lot more sense based on that. Okay, so now we have reached to the element right before the index, right? And we stop the report there. What we do next? We check if the current and the current.next are valid, right? Because we need to be switching those. So what we do is current.next is current.next.next. If the current.next.next is none, which is okay. So what would happen is if it was the last element, it would just point to the very last, it point to nothing essentially. But here's the thing. If the current.next is tail, right? If we stop like right before the tail, we would make our tail to current. So it just essentially removes the last thing. We are pointing our current next to the none, and we return true. Well, this thing worked out well. If none of it works out well, we return false. And yeah, get values is a way to like uh, print all the elements in the list. And yeah, so what we essentially do is we make an array, right? Empty array, and we start our current with the first element, self ahead and next, like the first original element, and we run the loop. Yeah, as long as the current uh, pointer is valid, we append its value to the array, and we increment the value of current. If it turns out at some point like current.next is done, it will go again, it ends the loop, and eventually it returns the whole array. And this is very, I think this might be a bit more complicated if you try to understand, but I would highly recommend drawing all these different conditions or different functions like get, insert head, insert tail, remove in a notebook on paper, and like try to understand how things work on their own by yourself. Make a lot more sense eventually. And I would highly encourage you to make a video like this of your own, just to know that you understood something, right? And yeah, this is the one I wrote. It made sense. Doubly linked list is actually a lot more easier to understand compared to regular linked list, because here's the thing. Doubly linked list is a linked list that also has like a previous pointer. So it is also pointing to an element behind it. So if you were to like add and remove anything, it's much more easier because we don't need to stop or loop through, or like we don't need to loop through it. We don't need to stop or do fancy things. We just know what to do with it. I'm not gonna go in detail of this code because like there are points where things get very fancy, like our self dot head dot next dot next dot previous is. So this looks complicated, but like I literally made like a diagram or like an example. I wrote an example in my notebook, and it is very intuitive and it's gonna make sense. Um, Yeah, the only difference is that it is a pointer pointing to the next element and a pointer pointing to the previous element. Very basic things. Yes, yes. There is one more thing though. There is one more important thing. In the single linked list, what we did is we created a dummy node with the value of -1, and we made our head and tail both point to it. But in double linked list, what we do is we create two separate dummy nodes of -1, and head points to that one, and the tail points to the other one. Now, self.head.next points to the tail, and self.tail.previous point to the head, which is very intuitive. If you make a diagram in your notebook, you're gonna be able to understand. First thing, what's gonna be the self.head.previous? It's gonna be none because initially it was none, and it doesn't have any value or anything, so it's gonna be none. What's gonna be self.tail.next? Because there is nothing there, so it's going to be none as well. The very similar way, there is insert front, insert end, remove front, remove end, also print. This is much more easier, but these things you need to like kind of figure out on your own. It is intuitive, but and also a fun exercise, but I would highly encourage you to do that on your own. Okay, there are queues. Okay, queue is like a, let's say if you go to like a bank, right? And bank, like queue is like a version of a single linked list, and which has properties like NQ and DQ. What it essentially means as, let's say a person joins a queue, they can only join in the back, right? But if person wants to leave the queue, they would have to leave from the very top or at the very front. That's how the queues work, right? Like the first person who comes in is the first person to leave, or first in, first out. That's what it means. So we would be designing that. For that, what we'd be doing is there's we define the nodes, right? In the init function, instead of creating dummy nodes, we would make left and right. We wouldn't be using where yeah, we won't be using head or tail. we will be using the right pointer and left pointer. And when we initially decide to design it, it would be just point new none. When we enqueue it, which means to add to the queue, we would make a new node, right? And as long as the right one, the right side. So when we make a new queue element, we would be adding from the right side. So if the right side is valid, or if the element exists, we would make the rights next to new node, and software right is should be new node here too. That makes sense. If the element exists, if it doesn't exist, we would both point to the new node, left, right. DQ, very similar. First, if it's empty, return nothing because there is nothing there, right? Now, we would, so in DQ, we would be returning the value. What we'll do is we'll find the value of the very first element on the left side. So self.left of val is the val, right? Now, self.left is self.left at next. So essentially, we are moving the left pointer, right? Now, here's what happens. If not self.left, so if it was just one single element, so this would become none because self.left.next was none. If this becomes none, we'll also make the right one none because it was the last element, and we'll return the value that was there, right? Print is very simple. You're just printing stuff. We run the loop as long the code is valid, and we start with the we're starting with the left. Yeah, and print is for the new line. That's it. Very simple, but I feel like if you try to visualize on your own, things would be much more easier. I would say take a paper and draw things and try to understand every single one of those function and see how it works, and try to code it then after on your own. You would be really good at it.